So if all goes to plan, today's video is going to show you how to make one of these, a trough planter with integrated rabbit run. Some time ago we made these planters for trees, which are square, and they're out of just pieces of 45 by 95 pressure treated batten. There's an internal structure, one in each corner, so batten going down in each corner, and the screws come on internally, so you don't get any exterior screws. And the planters we're going to try to build today will hopefully match that, so be of a similar style. Can you get 2.4 metre stock into a Volkswagen Up? Yes you can. Okay, so now we have our material back home. We can lay it out and see what it looks like. Not all pieces will be the same, so it's a good idea to see if you can tell which ones are straight. You'll also sometimes have a good face edge and a bad face edge, so you kind of want to think about which one's going to be on show. This timber might seem excessive, and in a way it is. It's kind of over-engineering, it'll make a very heavy planter. But the timber itself is actually quite cheap. This is CLS timbering, and it's designed to be multi-purpose building timbering. It's kiln dried and it's finished usually straight. A good thing in the shop to do is to pick one up and look along the length of it and check that it's not too bone or too warped. We bought two sizes, a larger 95 by 45 and a smaller 63 by 89. And weirdly with timber, often the cost is based on how many times they've had to either saw it or plane it, rather than the actual amount of material you get. So CLS timber, especially untreated, we bought pressure treated this time because it's an exterior project, but CLS timber, especially internal, can often be cheaper than even quite small pieces of batten. So it's worth looking at the catalogue or the price list where you've gone and figuring out what will be most efficient for you. Now in our case we bought these from a chain store in England called Wicks, and each piece has ended up costing roughly £5. They usually do you a discount if you buy more than 5, and sometimes the discounts aren't listed on the shelf, so it's worth checking on the website first what the multiple unit discount break is, because for example I only need 3 of these smaller ones, but actually I bought 5 in order to bring the cost down. These are the materials that I think we're going to be using. We'll wait and see as I build it as to whether we need anything else. So little screws just for fixing things in place, so some 3 by 30s and some larger screws for the main body of the jointry, which will be 5mm by 70. I go for this sort because they're self-cutting, so although I will use a pilot hole, they'll cut themselves in quite efficiently. Also they come with a star or hex bit, which gives you a little bit more torque for driving in the larger screws. The back pieces I'm going to join on with coach bolts, mainly because of the price actually, because taking these ones up to 100mm ends up costing you some money. Also the hex heads on those, you can drive them quite well. There are some... These are safe plates. They're supposed to be used on underneath floorboards to stop people drilling into electrical joints, but we're going to use them the other way up as feet for the legs of our construction. And finally some wire and hooks for the actual climbing wires of the planter. Our main point today is that we want to do as little cutting as possible, so we're going to try and design the planter so that we cut just a couple of times on each piece and we don't have any wastage of the wood either. That way it'll be easier to make, but also we'll save ourselves some money because we won't be wasting the actual material. Okay, check out the science. It's always good to have a diagram. This is probably the worst diagram in the world compared to what we're doing, but what I would like to do is to show you how I'm using it to help me plan the cut lengths. So like on the existing planters, I want to do the kind of brickwork interlocking corner pieces. Now that has 2 implications. It means that these side pieces will need to be different lengths to cope with the overlap. But also, if you notice, this will be a short side piece, this will be a long side piece, but for every short side piece there'll also be one long side piece. So I'm thinking that when we cut the long piece up, if out of each overall piece of timber we cut a short piece, a short side, alongside, and the front, that'll be the best use of material. Now I hope that that'll give us a width of somewhere around 400 millimeters. But let's do some maths and figure it out. Okay, bear with me on this. We've got two sizes of timber that we're working with. The pieces for the sides, 45 by 95, and the pieces for the legs, 38 by 63, and both are 2.4 meters long. So in order to build the sides in an effective and efficient way, I need these two different lengths of side pieces. So if I cut each of the larger poles at 1755, 345, that should leave a 300 length. Now when the saw blade goes in, it will change the lengths a little bit, but as long as I cut all the pieces to the same distances, it shouldn't really affect things very much. Now for the verticals, I want to use the slightly smaller wood stock. For various reasons I'm going to put it so the long edge runs parallel. So 63 plus the length of the longer side bits of 345 is approximately 400 millimeters, which was the width that I was looking for. So by making two cuts in each long piece of wood, we'll effectively make the front and the sides for each one, and then when they're all together it'll make a planter around 6 feet long. Around 6 feet long, I'm happy with it not quite being there. So in fact it'll be 1755 plus the width of the end piece of 45, so it'll actually be 1800, which is near enough 5 feet 11 inches, and a little bit more maybe, so just under 6 feet as a total width. So I am happy with that as a plan to proceed. Each piece of wood, two cuts, bang bang, done. Once you've got your material out, measure it up and mark it out. Note that on mine I've got manufacturer shipping marks in various places, so I'm going to do all my marking on this face so that we don't spoil the face that you'll see when it's finished. Once you've got your cut lines out, measure it again. Always measure twice and cut once. Now just a quick tip for miter saws. This is a very cheap miter saw because I hardly ever need one, but almost every time I use it I have to set 90 degrees and make sure it's square in both planes, because even just putting it in and out of its box seems to move the blade so that it doesn't cut straight anymore. Now on this project I know that there are a few situations where I'm going to want a 45 degree cut, so I'll be moving the blade and kind of moving it in order to do the 45 degrees. If your miter saw is rubbish like mine and you have to reset 90 degrees all the time, try and make sure that you mark up your work pieces so that you can do all the 90 degree cuts at once and then adjust it and do the 45 degree cuts, and you don't have to keep moving between doing 45 degrees and 90 degrees, because either it'll take you ages setting the saw up each time, or you'll cut corners and you won't set it up at 90 degrees, and then that'll cause you all sorts of problems when you come to assembling the pieces of wood. Now my least favourite part of the whole build. On those pieces that have just been cut, and in fact all the pieces that are going to be on show, I'm just going to run a normal third sheet belt sander around the corners to take off the burring that we have, and also just give a slightly more appealing rounded effect to the corners of each piece. And it takes ages. So just looking quickly at the result of that sanding, so the edges of all of the pieces that will be joining together have just been rounded off. It's not particularly neat, it's not particularly consistent, but what we'll find is that when they're matched together it produces a much nicer finish than the rough sawn, and certainly the bit with all the burr on it that we had before.